Hi, Logan. So this is the help that you just sent me on the email with the translations of the triangles. And so I'm going to go ahead and share my screen and just talk you kind of through this problem and see if you understand it, okay? Here is the problem right here. And it says that below are triangles ABC and DEF. So here's ABC and DEF. And we assume that AB is equal to DE and BC is equal to EF and that AC is equal to DF, okay? And here's a rough outline of a proof. And so what we're going to do is we're going to actually just follow the proof and see how they figured it out, okay? All right, and so they said we can map ABC using a sequence of rigid transformations so that A prime is equal to D and B prime is equal to E. So what they're going to do, and let me go ahead and show you kind of what they did here. I'm going to take a picture of triangle ABC, okay? And I'm going to put it right here. And then I'm going to say, okay, look, this is A prime, this is B prime, and this is C prime, okay? So that we understand this is a different triangle. And we'll just put these together so I can just move this as an entire thing, okay? So what they did is they just took this and they said, okay, look, the first thing they did is they used a sequence of rigid transformations. And so kind of look at what happened. They would have slid it over and then they would have slid it up to get it to line up right there, right? And so they get that A prime is equal to D and B prime is equal to E, okay? So that's kind of the first thing that we want you to kind of understand, that that's how they did that, okay? So that's the first thing, using a sequence of rigid transformations. And then if C prime and F are on the same side of DE, so they're saying if these two are on the same side, then C prime would be equal to F, okay? And that's what they're trying to figure out. And then if we reflect ABC across DE, then C double prime is equal to F and A double prime is equal to D. So that's basically all they're saying here is they're saying, look, if I now just took this and I reflected it, okay? So I'm going to tell the computer that I want to reflect this. So we're going to reflect this in the x-axis. So we'll reflect it in the x-axis, right? And so when we do that, that gives us that reflection. And if we lay that right here, we're going to see that that's going to lay right on top of the original one, right? And so that's what they're trying to get you to kind of see, is they're like, look, we did a translation where we took it from here and we slid it over to here. Then we reflected across the x-axis and then this landed here, showing that these are exactly the same. And so that's what they actually did. So the first thing they asked you was, well, how did they show that the triangles were congruent? And what they did is they actually mapped one figure onto the other using rigid transformations, okay? So we didn't change the shape, and that's what rigid means. It means that it stayed the same, okay? So that all the sides, the side lengths and everything, the angle measurement stayed the same. All we did was we either slid it or we reflected it. And so that's what we actually did to do that. So then it says, what triangles did we show are congruent? Triangles where all three pairs of corresponding sides have the same length. And let's take a look at this. We said that this length and this length are the same, and this one and this one are the same, and this one and this one are the same. If we had where their lengths were not the same length, then we could not prove that they were congruent. So this is a thing that has to be true, because congruent is same size, same shape, and so they have to be the same size. So this is true for all triangles that are the same size. So hopefully that helped you out with that explanation. And then I'll get that loaded up for you. And if you need any more help, just email me. Okay? All right. Bye.